Welcome to General Structures 2, Lesson 3, Example number 2. And it asks us to find the forces in members 2, 3, and 3, 4. 2, 3, and 3, 4 on the following. So 2, 3 is actually this one right here, and 3, 4 is right here. But I'm going to rename those because I am weird like that. That's just how I rolled. I'm going to name them A, B. So they want to know BC and CD. I'm going to call this D. I'm going to call this E, F, and G. That's personal preference, just what I'm used to. And the first thing I would go ahead and do is figure out what your angles are here. And that can't be horribly difficult. What you want to do first is use your, and this is going to be big on the your SOHCAHTOA stuff, your trigonometry principles. First thing I would do, all that junk kind of shies me away. So what I would do is say, okay, what do I know? I know this is 20 foot. Actually, I didn't know how tall it was. How tall is it? 10 foot. The whole thing is 10 foot tall. So let's do this. 10 foot. Alright, so we know this is 20 foot. If we make a triangle like this, and this is 20 foot, and this is 10 foot, I'll erase that. So we can figure out what the angles are. And let's go ahead and do that. So if we have a right triangle, 20 foot and 10 foot, we can do the tangent. I'm going to write that down here. You can do tangent, and we'll say this is theta right here. Tangent of theta equals opposite over adjacent. Remember, TOA, opposite, is right here, so that's going to be 10 foot over adjacent, which is 20 foot. So we just need to do the inverse tangent of 20 over 10, which is 0.5, and you get 26.56 or 26.57. Let's round up. So I'm going to go ahead and get rid of this. And if this is right here, if this is 26.57 degrees, that's 90. Then this down here will be, actually you could just say opposite interior angles, 26.57 degrees. Alright. And we're probably going to have to do a couple videos on this because just finding the angles is going to take a little time. But now we come down here, and what do we want to find? Well, we need to find this angle right here, and this angle right here, I guess. So, how can we do that? Realistically, you probably wouldn't have to figure out all these angles. You could just cut it. As long as you know that this right here, since that's halfway up, is going to equal 5. Whoops. Is going to equal 5 foot. And that's true because it is half of that, and they're similar triangles. And I hope that makes sense. I think that intuitively it should make sense. It's half that way, and it's the same slope, so therefore it's going to be half. Alright, so in the end you don't have to do this, but I think it's a worthwhile thing to go back, and it gets you used to doing this trig. And in the end, if you're designing this truss, you want to know what the angles are just to check yourself. I wouldn't go through this stuff because there's so many little mistakes you could make going through it, where just go ahead and figure out what the angles are. It's not going to hurt anybody. Alright, so let's go ahead and continue on. I guess what I would do next, and this may not be the best way to go about this, but this is what I would do, is I'd take this down here and I'd actually cut this into a right triangle, 2 right triangles. So once again, I would not recommend this for most people, and you can go about it whatever way you wish, but this is how I would do it because this is how I feel most comfortable doing it. I divide that into a right triangle. I have a right triangle right here. I have a right triangle right here. I know I already have 26.57 degrees, and there might be a better way to do this, but I don't know. I don't want to. I didn't even look at this problem before I started, so I'm trying to explain or show you how I would do this right off the top of my head. I'm not giving it any previous thought or anything like that. I'm just, right now, nothing pops out at me. Now, it may be better to say, oh, well, you could do a right triangle right there, or maybe there's something I'm not seeing that's easier to do, but this is what I see first. So what we can do is say, hey, we've got a right triangle here. Okay, well, we know we have 180 degrees in a triangle. So I'm going to take 180 minus 26. Let me get rid of my 180 minus 26.57. And that's 153. That does not make any sense right now. Oh, I forgot to subtract 90. Yeah, like I said, it's getting late. All right, so 180 minus 26.57 minus 63, or minus 90 equals 63.43 degrees. 63.43 degrees. All right, so that is where we are at. And now we know what on this other triangle. Well, you're like, oh shoot, I got everything over here. Well, we do know one thing, and we know this equals 3 foot 4 inches. So that equals 3.33 repeating foot. All right, and knowing that, and you also know what? You know that this dimension here is 5 foot. And from there, you can also get the dimension of this right here. Simple Pythagorean theorem. Let me get rid of that real quick. All right, 5 foot. And we're going to need to know that dimension. Actually, we should figure out this dimension too. And as you can see, this is going to get messy if I try to record all these dimensions, but I'm going to because I like things to get messy. All right, so I'm going to go back over here. Before I do this, actually, let's go ahead and do that. We know that this is 10 foot. That's 3 foot. Yeah. So we're just going to do the Pythagorean theorem. 10 squared plus 5 squared. And the square root of that is 11.18. So this is going to be 11.18 foot. Down here is 10 foot. Up there, right there is 5 foot. And then coming over here, we're going to do the same thing. 5 foot squared plus 3 plus 4 divided by 12 squared. And the square root of that, we get 6. Let's just say 6 foot. I'm going to do that again. Yeah. It's a little over 36, the square root of 36, which is, give or take, 6.01, you could say. Let's do that. 6.01 foot. All right, and that's the dimension of this member right here. All right, so there we are. And we'll need to know, well, hopefully you know that this will also be, if this is 11.18, this will be 11.18 foot. This is going to be, it's kind of hard to write sideways, 6.01 foot. And we'll say this is 13.4 foot. And I think we're good. We'll write this in 63.43 degrees. Alright, and we haven't figured out what this angle is yet, so let's go ahead and do that now. And we want to figure out what this angle is, which is theta. So we'll say that we can do tangent. You could do sine or cosine as well, but tangent's easy. It's TOA. T opposite, this is 5 over adjacent, which is 3.33 repeating, and that gives you the inverse tangent of 5 divided by 3 point, lots of threes, good enough, 56.31 degrees. 56.31 degrees. Alright, now we have that entire triangle, which is good. That is a good start. Now, it gets even more confusing when you try to get to this triangle right here. what would the easiest thing would be just go onto a drafting program and actually draw this darn thing in, and it would take you infinitely less amount of time to figure out what all these dimensions and angles and whatnot were, so it'd make it a lot easier. But we'll go ahead and do it by hand just for fun. And going back and looking at this, remember this angle right here was 63.43, so we actually have to go out and figure out what this angle is and add it to 63.43. As you can see, this is getting confusing and just generally frustrating. If you want to, go ahead and skip to the next video. Maybe the second video, but I'm going to go ahead and continue on with this, and you can just see how much of a pain this could be if you have to do it by hand. Alright, and we want to figure out what that theta is. It's the opposite, which is right here, over the adjacent. It's the opposite to its inverse tangent, which is 3.33333 divided by 5, and you get 33.69. So together, 33.69 plus 63.43 equals 97.12. Alright, so this angle up here equals 97.12. And does that make sense? 26.57 plus 56.31 plus what we said, 97.12 should give us 180, and it does. We are correct. Yay! Celebration. So what did I say? 97.12. Alright. Degrees. 97.12 degrees. And you know from this, if that's 97.12, this is a 180 degrees. I forget what the identity of that is, or whatever it's called. But it's 180 degrees. And therefore you can take 180 minus 97.12 and you get 82.88. degrees for that right there. Now we move on to another triangle, and if when I look at this triangle, it's nasty and I'd have to cut it up and I don't have anything obvious. I'm going to look at this triangle, which if we, what color am I using here? If we cut it right here, put a 90 degree angle, what do we know? We know this distance is what? Half of 13'4" is 6'8". And is that going to be enough? And we know 10 foot. Yes, we know 6'8" and 10 foot. And that, so this is 10 foot right there. 6'8" and 10 foot. Let me erase that real quick and put it down here. We got all that information that we needed from that diagram. So 6.66 foot, 10 foot. We can figure out this angle, we know this angle. And then we'll just double that because this is, and we'll don't have to double that, but we'll mirror it over there. Alright, so let's do tangent of theta. This is going to be theta 1 equals opposite over adjacent, which is going to be 6.66 over 10. Inverse tangent of that is 33.69 degrees. So this is going to equal 33.69. Let's go back to yellow. So when you multiply by 2, it's going to equal 67.38 degrees. And then what you could do is just take 180 minus 67.38, divide that by 2, since we know 180 and then these two are equal. Or you could go down here and do the tan, which I'll do both 5 times. This is going to be 56.31 and 56.31, which, if you look at it, these angles are equal. 56.31, 56.31. Interesting. So what we could do to get this angle is take 180 minus 56.31 times 2, get 67.38. So this angle equals this angle. Alright, and then we can take Actually, I'm going to go ahead and stop. I have 10 seconds left. What now I'm going to do is figure out these angles on the next video, and then we're going to go ahead and do the method of sections.